Alright, so for problems 1, 2, and 3, I thought I'd do them together on this program GeoGebra. And what I've done is I've written two equations of two lines right here, line A and line C. And I've given one of the two lines a value that can change for M and B. So when we look at these lines, if the slopes are the same, so both slopes have a slope of 1, we see that they are parallel, and there will be no solution. When we ask what it means to have a solution to a system of equations, we're asking you for any points, x and y, that will give you a true answer in both lines. What does that mean graphically? It means the lines will cross. Well, when the slopes are the same and you have two parallel lines, you can see that there's never a point that crosses, so there's no solution. If I change this value here, the y-intercept, you can see that that parallel line gets closer and closer to the other parallel line, and at some point, if I have exactly the same value, they'll be right on top of each other. And again, it's not defined by one single point, but it's defined as every point. So when you see a single line written on a piece of paper, it's hard to show two lines on top of each other. That's what's happening. You have two lines that are exactly the same line, and they're overlapping. So in this case, you would call this many solutions. So what's the other case? The other case is what happens when the slopes are different. And when the slopes are different, you can see that the slants change, and all of a sudden, these two lines intersect. The point they intersect at is the solution. It happens one time for straight lines, and you can see right here that it's just one single point. For example, right here it's 2, 5. So the intersection between these two lines is 2, 5. That's how you solve problems 1, 2, and 3.